Welcome to today's webinar, how to avoid bonding mistakes. Welcome that you also joined us again in such a great number. As always, we have a few slides here where we discuss the topic theoretically, and then we move over to our application table and do some practical demonstrations. Today, it will be a little bit more theoretical part because we have to explain a lot of different systems and some mistakes which can be done, and we cannot reproduce them all on the table right away. So I'll view a little bit more pictures. Anyhow, if you have questions, as always, just write into the chat, and Otello behind the camera will answer them or pop them through to me, and I will answer them directly. Good, let's start. How to avoid bonding mistakes. As you know, especially in the stone industry, natural stone industry, a lot of objects, a lot of nice buildings, countertops, everything is glued together. So you can do a lot of things with adhesives and bonding in general. When you think about aeroplanes, for example, the wings, everything is bonded together. So you can do fantastic things with adhesives and glues, but that the glues can perform in the right way, you have to have in mind a few a small checklist, and we will talk about this in the following 45 to 60 minutes. Yeah, bonding in our area, in our field, is usually countertop bonding. You know, the mitred bonding at the countertops. This is usually done with adhesives. Also objects like that, the front cladding here, or the mitred bonding again. So we can do a lot of nice things with adhesives in the natural stone industry. Or when I look at this massive monument here, this is at a temple which we built in India. I think the temple was moved later on to Vietnam, but all these parts, all these stones, there is no steel frame, nothing. This is massive stones, and all is only glued together with epoxy adhesive. So you can do fantastic things. Or when you see at this video here, it looks like one big piece of stone, but when you come closer, when you look, there's a lot of stone pieces glued together. Here, there is the joint, but when you choose the right product, the right application, then you can do a fantastic work. And this looks like one big unique surface. Good. So to do all that, we have to follow a small procedure. First, we have to choose the right adhesive for the right application. So is it an outdoor application? I have to have in mind weather resistance. Yeah. Have I to have frost thaw changes? Do I have a lot of water, like on a swimming pool surrounding or at a fountain, for example? This is important. Not all products, all adhesives can work in this environment. So I will talk later a little bit about our different adhesive groups or systems which we have. What are the advantages? What are the disadvantages? UV stability. So in general, all of the adhesives are UV stable. So they don't dismount or dismantle from UV light, but they can turn yellow after a while. Yeah, not all of them, some can change the color. So this is important, especially when you have like such a nice repair restoration work where you adapt color and structure, and then after, let's say 1-2 years, it looks like that, then all of your hard work is gone. So you can have to have this in mind. Yeah, I think no words to that. White Carrara used some product which is not UV stable. You see the joints, you see the yellow patches all over the place. So even grinding and polishing here afterwards will not solve the problem. The joint will still look quite yellowish. So this thing was definitely not the right choice. Rigid or flexible. This is always has to cross your mind when you have different materials, like in this case, a steel frame, a stairway, and a natural stone, which you want to glue to that. So everywhere where it comes to different substrates, you have to think about, could there be some temperature changes? So interior-wise, where there's always a constant temperature between 18 and 25 degrees, for example, there is no much tension there or not much expansion. But when it comes to outside, where we have huge temperature changes, yeah, from -20 maybe to +35, 40 degree in summertime, maybe also sun shining on the stones or ceramics. If it's a dark one, the stone heats up maybe to 60, 70 degree. So there you have a big change of temperature. And so also you have a different expansion of the materials. All of you know steel has a much higher expansion than, for example, stone and ceramic. So for that reason, you have to have flexible adhesives in mind. Of course, working time has more something to do with your ability to fulfill the task. Yeah, when you have let's say a very difficult structure like that, where you have to put small pieces inside to adapt them to check which is the right one, there you need time. So you need a product which has a long working time to fulfill here all the task and the adaptation. If you're working on the resin line or on the polishing line, you want to have it fast. It's an online process. You need a fast curing and working time product. Good. Let's start with the overview over the different adhesive classes. So when it comes to interior application, okay, first of all the products I show you, you can use interior. Yeah, but a few products you can also use exterior. And indoor wise, you can only use polyesters or epoxy acrylates. These products are exclusively for interior applications. What are the advantages of polyester? They are very fast curing. Yeah, so after 30, 45 minutes max, you can grind and polish. Also, there comes a short processing time, yeah, with that speed. But when you know it, you can handle it. And usually it's used for filling or bonding natural artificial stone. Polyester mastics are usually the products. Our marble fillers are usually a class of polyesters. When it comes to epoxy acrylate, some people get confused by the name. They hear epoxy, and epoxy, they know epoxy I can use outside. No, epoxy acrylates not. Yeah, epoxy acrylates, they, let's say, are between those two worlds. They are fast as a polyester, nearly as strong as an epoxy, but still they are not 100% frost or weather stable resistance. So where is the epoxy acrylates used? They have a higher bonding power. So they are usually more used for ceramics, engineered stones, artificial stones, which are very dense, where the glue cannot, let's say, grab the stone quite proper, where the material is so dense and maybe sometimes very smooth. So there you need a product which has a higher bonding strength, and the epoxy acrylates, which are filled in our platinum or color bond glues, are perfect for that. So high adhesive strength. They're easy to color because they are usually have a light color. So they are nearly transparent, milky white transparent. So they are easy to color, to adapt color for your work, and usually you can certify them food safe. When it comes to outside bonding, you have to go for epoxy resins, which will be our Akepox range. They are fully frost-thaw stable, weather resistant. They have a very high adhesive force. They're usually solvent-free. They can be food safe certified, and they have a very low shrinkage behavior, which is important once for frost-thaw stability and once for filling properties, but I come to that later. Also, what you can use outdoors is high-quality polyurethanes. Not every polyurethane is suitable for outdoor bondings. Yeah, there are quite cheap ones. They are not suitable. But for example, our Everclear range, they are suitable for outdoor applications, frost-thaw stable, and they are completely UV stable. So they don't change the color. No yellowing. Yeah, when you have a white Everclear, you fill a hole or you bond a joint with a white color, this stays white in 1, 2, 3, 5, 10 years. So this is important when you work with light colored or white ceramics, artificial stones, or even marble, for example. When it comes to marble, the Everclear has another advantage. It has no bleeding. So sometimes you can see in very, let's say, crystalline absorptive marbles that when you bond them together, doesn't matter if it's like a polyester or epoxy acrylate, sometimes you see left and right of the bonding joint like a small dark line. So this we call bleeding. This is because the polymer gets absorbed by the marble, cures then, so it's all fine there, but it leaves a little bit of dark line. So this depends on some white marbles. They have these issues. So if you have seen that on some stones, then remember the Everclear range does not do that. So no bleeding there. This would be a right choice for that. So this is a short overview of this 4 big groups which we have in our program. Are there any questions already, Otello?
Hello, everyone. No, currently no questions, but they will come soon, I guess.
Good. So now let's start with the common bonding mistakes. What can be done wrong, or what is sometimes done wrong? Yeah, selection of the adhesive. So that means the wrong adhesive was chosen for the application. Yeah, for example, they use indoor adhesives for outdoor applications. For example, polyester for outdoor bonding, which is, let's say, have a lot of frost out changes, is in a northern European area, or Northern America installed. So there you have some frost out changes, and you used a polyester, for example. Then what can happen, especially when you have a limestone, you could have a deep bonding of the glue, of the adhesive, because it's not 100% frost thaw stable. The temperature is a problem, but usually it's a combination between water and freezing, which makes the problem here, which causes to a delamination and let's say a dismantling of the bonding. So just have it in mind. If it comes to outdoor, use a epoxy or proper polyurethane. Yeah, I know in some warm areas, let's say southern Europe, like southern Spain or India, for example, they use sometimes also polyesters for outside bondings and fillings. This works there more or less, because they only have heat. They have between 20 and 35 degree temperature changes. So this could work, but as soon as it drops to 0 when it comes to impact of water as well, then you will have the problems. So better stay with epoxies or polyurethane when you go for outside applications. Then, as I explained earlier, non-consideration of expansion effects. You used a rigid glue, so a solid epoxy glue for maybe a bonding of 2 different substrates, like steel to stone, and there was some movement, some expansions of the metal, and then you can have a problem. Like this, as I showed you earlier, in interior-wise, maybe there's not so much a problem, but when you have it outside, definitely there will be some movement, some expansions of the metal, and if you'd have a rigid bonding, for example, with a polyester or epoxy, you will have some bonding issues. And so better here use some flexible glue. Or you can see here a steel bar very tightly glued into with a rigid glue into a stone. And maybe there was some heat, some sunlight on the stone. It becomes heated up 40, 50 degrees. The steel tried to expand, but it was through the rigid bonding directly, the stress was given to the stone, so the stone could crack. It's not a must, but it could crack. So in this type of application, usually a flexible or a semi-flexible adhesive would be the better choice. There was also an article in a technical journal in Germany. It was it's called the Naturstein. That's a technical journal, and it was published February last year. There was sandwich under tension. So what happened? They made a table of 4 millimeter ceramic, and they rigidly glued it to a wood, 16 millimeter wooden board. So it was interior, so there was not a problem with the heat. That maybe there was an expansion from the heat. But it was because it was located in the dining area, but there was moisture somehow. Yeah, maybe there was a steam cooking or a lot of humidity in the room. So the moisture caused the wood to expand. Yeah, and the wood expand, and because of the moisture absorption, and then because of this rigid glue, the tension was passed on directly to the ceramic, so the ceramic cracked and failed. So this bonding failed. So in this case, they should have used a flexible glue. Yeah. So it's not only the heat which you have to have in mind, it's also the substrate itself. Yeah, if they used probably maybe aluminum honeycomb for that application, interior wise, maybe then nothing would have happened. Yeah, because the aluminum does not absorb any humidity, but they used wood, so this absorbed, then it starts to bending, and then the problem occurred. So just to have it in mind, different substrate bonded together, you have to be aware of humidity and heat expansion. Okay, and I think what could be some solutions for that, we show at our application table. So, yes, where we start here. Yeah, this is, for example, yeah, maybe show it in the overhead camera. Yes. So we have some steel bars bonded into a stone, and you can see this is a little bit flexible. Yeah, so this is an adhesive, but it is a little bit flexible adhesive. And when I still move it, so it's not wobbling around. So this is quite rigid, but it still stays flexible. So this would be our Akinova range. If you use an elastic, Akinova elastic or Akinova rocket, is in this case doesn't matter. The expansion is enough. So this could be a solution for that application. Yeah, when it comes to different substrates, always have in mind temperature, expansion. Yeah, can create a lot of tension and force, and better use in this case something which stays at least a few percentage elastic. The other example, this would be the table I was just talking about. Yeah, thin ceramic glued onto some wood. Yeah, and the wood absorbs water and it starts to move and bend. And here we used our Akipur. So this product stays a little bit elastic and don't transfer all the force, all the tensions to the ceramic. So when you have different substrates, think about elasticity. Yeah, for example, this would be the Akipur 150, which we used here. You can use it with a 2 spatula, 4 millimeter, 6 millimeter 2 spatula. Then you place the ceramic or the natural stone on the wood or aluminum honeycomb, and then you have no issues with any tensions or expansions. Good, Otello. No questions? Then we move on.
No questions for now.
Good. So far from examples from elastic bonding. Good. So now the third thing you have to have in mind is by the choice of your adhesive, the reaction-induced shrinkage. So some products, some polymers, when they cure, they shrink. And you have to have this in mind, especially when you fill and repair a lot of holes, yeah, and bigger holes. You can see here, there was a polyester used in this video, and this has some shrinkage, yeah, just during the chemical reaction. It has some shrinkage, and you can see it becomes very loose. In this case, he used the spatula and only 1-2 clicks, and the whole thing comes off because there was no proper bonding. So polyesters are a special case because they have, depending on the product, between 2 to 7% shrinkage. So imagine 10 centimeters of a hole like this one like this one. Yeah, approximately 10 centimeters, and you have 7% shrinkage. That means 7 millimeters. Of course, there will be not a 7 millimeter gap because the shrinkage will be everywhere. So it will become from the top a little bit, from the left, from the right, yeah, from the top and from the back. So there will be a complete shrinkage. Yeah, so that means the bonding will get looser, and then when you have maybe a maintenance machine, cleaning machine on the floor, they come with the water and a lot of with the brushes, and after a while they rip out these fillings. Epoxy would be ideal for that application. Yeah. So when it comes to filling of bigger holes, we say larger than a €2 coin. So this would be about 2 to 3 centimeter maximum. When it comes to a bigger hole, use always epoxy-based product, because the Akepox line, they have a shrinkage between 0.3 and maybe 0.7%. So hardly any shrinkage. So they would be better for that application. I think you can see it here in this short video also better. It's a time-lapse video, so applied some polyester and some epoxy, and we let it cure. So you can see on the left side, it cures, and after a while, even you have here a small, let's say, crack, because there's a lot of tension. Of the shrinkage, there's tension in the material. And now you can see better, it's wobbling around, and you can just get it out of the lid, and the epoxy stays as it is, because the polyester had a shrinkage and tension. And this combination of the tension, it's in its material itself, because you used a lot. So that does not mean you can bond with polyester, because when you usually glue with polyester, you have a very thin line. So there's no issue there. But when it comes to bigger fillings, bigger holes to repair, the polyester has some shrinkage, has some tensions. And then it's also a reason why it's not frost door stable. When it comes in combination with water and temperature changes, then the water can go into small cracks and openings, and then cause this debonding. Yeah. Here you can see the difference. Yeah, the lids were originally the same size, but after curing, you can see the difference. Yeah, it's quite a big difference between the polyester and the epoxy. The epoxy stayed as it is, and the polyester did acquire some shrinkage. Yeah, generally, when it comes to this big filling of holes, yeah, even if you use epoxy, what we always recommend is, also because it's a let's say, it looks nicer. Yeah, when you adapt here only by color, of course you can adapt the color quite good, but still you have here lines and you have stone structure. So what we always recommend, use as much stone, crushed stone, what you can to throw into the glue. Yeah, doesn't matter if it's polyester or epoxy. When you do repair work and you have a spare piece of stone, crush it, make small particles out of it, 2, 3, 4, 5 millimeters. Yeah, throw it into the glue and use that then for filling. But when you do that, first mix the two components. Yeah, put the hardener and the polyester, or put A and B together when you use epoxy, for example. Mix all the components, then throw your stone particles in it, and then you can start filling the big holes, and later on the grinding and polishing. So we have done that. So yeah, this was the selection of the adhesives. So these 3 things you have to have in mind: weather resistant, yes or no, rigid or flexible bonding, and shrinkage. Yeah. What do you want to do? Do you want to bond or do you want to fill? When you want to fill, epoxies. When you want to bond, depending interior, you can always use a polyester or epoxy acrylate. Now, we have now the right glue. Now it comes to the preparation of the bonding surface. Yeah. When you look at that, this is a ceramic, or porcelain. Yeah, like Decton, Neolith, Laminam, or how you call them. So they are very dense, very strong materials. And when you cut them, usually when they are cut by diamond blades, they are so dense and the cut will be so precise that this will be the surface coming out after the cut. So it's like a polished surface. There's no good adhesion on a polished surface. You always need a rough surface for good bonding. So when you have that, and you check your ceramic, or also with a very dense stone, it could happen. When it looks like shiny and glossy, that's too smooth. You have to roughen it. And when we talk about roughening, don't go with a blade or with a diamond disc and make only this lines here. Yeah, something like that. That's not roughening. This is just making a few lines. This is not a sufficient roughened surface. A surface must look like that when it should be a good, proper bonding. Why? Because when you do the cut, this scratched or cut surface, you will only have a few particle areas which are scratched. So of course the glue will go inside, but then maybe you will trap also some air inside. So it's always a risk, and it can reduce the adhesion. So when you have a proper roughed surface, you have a huge contact area between glue and stone. So it can really grab into the stone or in the ceramic, and this improves drastically the adhesion. So we have done tests without a roughened surface and with a rough surface, and it's the tensile strength tests. When you have this tensile strength testing machine, there are big difference. Yeah, so always please roughen the surface. Then the surface is rough, that's okay. Then they must be clean. Yeah, dirt, fingerprints, oily, sticky fingers, maybe some remains of some impregnations or some penetrating sealers somewhere. So this has to be removed. Yeah, this looks good. This doesn't. And dust is a very important thing as well, because usually you cut the slab or the stone or the ceramic, and there is the water and there's the dust in the water, and this dries up on your cut surface. And this has to be removed. Sometimes you can hardly see it, but it is there. So this must be really proper removed. Imagine when you want to make a pizza dough, and you slam it on your kitchen table. Usually it sticks. What you do, you take some flour, some dry flour, throw it on your table. Then you put the pizza dough there, and then suddenly you can move it. You can move the pizza, and you can flatten it and take it off the table and then put it in the oven. Yeah, but imagine the flour is your dust on your bonding area. So you put the glue on top. So this dust will cause a not good bonding to the substrate, and later on maybe dismantling of the bonding. Yeah, so dust must be removed. The surface must be dry. We come to that later, and it must be free of fingerprints and dirt. Especially when you have like this miter bonding, this is countertops with a front panel, and they used foul grooving technique. This foul grooving technique, they create some lines here as well, and in these lines, in these areas, usually a lot of dust, wet dust, sticks there, and when you have a white material, you don't see it. Use a proper brush, a scrub brush or something. Use a solvent-based cleaner or alcohol cleaner and brush this area really tight, really proper, so you remove all the dust and the fingerprints to get a good bonding later on. So now our bonding surfaces are prepared proper. Now it comes to dosage and mixing. Some mistakes could be done, especially when it comes to the mixing ratio or the hardener quantity. You have polyester and epoxy-based products. They usually have this small hardener tube where it says 1 to 3% hardener, for example. Don't extend that. More hardener does not mean the whole bonding or the glue gets harder. It only gets faster, warmer, more yellowish, more color changed, and less adhesion. It looks like that. We have here put 1, 2, 5, and 10% in a liquid polyester resin. And you can see what's happening. In the beginning, all the resins look more or less alike. Of course, the 10% looks quite whitish because there's the hardener inside, 10%. And now there comes the time lapse. It's curing. And I think you can see quite good what happens. The 5 and 10% become really yellow and really hot. So they have a lot of shrinkage. They have a lot of tension in the system. They get yellow. So there is no advantage of using so much hardener. Even if you want to color it white, I think there's no chance to put some white in here and you get a white glue out of it when you have done so much hardener inside. So all your color adaptation, which we have done before because you want to do a proper bonding or proper filling, goes all into the wind when you throw too much hardener inside. Good. So this was the hardener. When it comes to epoxies or polyurethane, they have a how you say mixing ratio. So the Akepox, for example, they have a mixing ratio of 2 parts A and 1 part B. So also this has to measured quite proper to not get any problems. So let's say we have done that right. We have mixed the product, or we have measured the amounts right, but then we do a poor mixing of the adhesive components. So this is a polymers. They are 2-component polymers. So all A and B component, they have to get in contact with each other to get a proper curing. Because if not, you can get these results. Yeah, they filled a joint here with some epoxy, for example. They did not mix it right, and all the remaining monomers or polymers, maybe the excess of A component or excess of B component, you never know what they mixed wrong, stays and moves into the stone, into the capillaries, and it will discolor it. And this stays like that. There's no way of cleaning it. So once your glue does not get hard proper, yeah, your bonding is not proper, and you also have additionally some really dark bleeding into the stone, which will create this effect. Maybe better visible is it here. They used white marble. They used these pins to mechanically fix them from the backside, and you see exactly where they mixed wrong or dosed wrong. Could be both, a wrong dosage and a wrong mixing. Here probably it was good. Here it was not good. Here it was good. Here it was not good. But mostly it was not good. So here this guy did a real great job and messed up all of this white marble. So this is really important. Mix proper, weigh proper when you have to work out of a can. Then weigh proper your amounts, especially when it comes to epoxies or polyurethanes. For example, when it has like a 2-to-1 mixing ratio, it's like 100 gram and 50 gram. There will be no harm if you use 52 gram. But it should not be like 170 gram. If it's a 2-to-1, it should be more or less in this range. Usually it goes fine most of the time, but when we get send pictures like that, it's a no-brainer. There was some mixing or dosing mixture failure. Good. Otello, there was some questions. I think you answered
there's
something.
One interesting question from a viewer. He's asking, is there a possibility to mix the glues together?
What type of glues?
I think it's about epoxy. Yes, because we're talking about epoxy.
Different epoxies probably.
Yes. No, it's writing yes, different epoxies. Yes.
Okay. Yain. Usually not. Because when you look at, for example, our Akepox 5010 is a 2-to-1 system. Our Akepox 1005 is a 4-to-1 system. So they cannot mix in each other, because I know what maybe the question is. People, they have a liquid one and a pasty one, and they want to have something in between. It's not really working. It's only working in a few rare cases when it's the same system. Like for example, our Akepox 5000 and our Akepox 5010, they are both a 2-to-1 system, but also here you have to mix first A and B of the one system, A and B of the other system, and then mix them together. But if you want to do that, better call us, write us first, then we can approve it. But usually it's not recommended to do that. The product, they have their mixing ratios, don't mess up with them, especially if they are different consistencies. So in some real rare cases, it's possible, but usually not.
Another question, Johannes.
Okay.
Is there a possibility to remove these bleeding effects?
No. As I said earlier, this is remaining A or B component. Yeah, it's a liquid resin or a paste resin which penetrate in this capillary, and there's no way of cleaning it. You can go with a flame and try to burn it, but it's not working proper. Yeah, if this is caused by a wrong dosage and a wrong mixing, then usually you have no chance. Good. No more questions or? Okay, good. Okay, then let's show that. Yeah, where have we been? Yeah, exactly. Okay, so cans, this is Archipox 5000, a liquid epoxy, 2:1 mixing ratio. So there is, usually we say you have to weigh them, yeah, with a scale, weigh your 20 gram and 10 gram, for example, in some cases, but then you have to check what it's written on the can. If there is written per weight or volume, yeah, then the density of the product is 1:1, like 1 gram per square cubic centimeter. So here, in this case, you can use, for example, a cup with some scale linings here. Yeah, for example, in this one, maybe you can see it. Yeah, here you can see these lines. Each of those is 50 milliliters. So in this case, I could fill it up to 2 lines. So it is 100 milliliter, and then I add 50 of the B component, and I have the right mixing ratio. But this only works with liquids and where the weight and volume is 1:1. So when it comes to filled products, like filled epoxies, like for example, our Archibox 2030, for example, or some G-like products, it's not always the same. So maybe there is the volume mixing ratio not 1:1, but maybe 7:2 or something weird like that. So here you have to use, for example, this is Archibox 2040. So I think here's the density 1.7 or something, yeah, gram per cubic centimeter. So no chance to do this by volume. Yeah, so here you have to use a weight, a scale. Yeah, but when it's 1:1, you can use something like this, a cup, or you take like these scoops, two spoons of A component, 1 spoon of B component, then it works. When it comes to cartridges, yeah, no trouble for you because the mixing ratio is already given by the cartridge. So you only have to put the mixing nozzle on it. So there's no problem here. But when it comes to cans, especially epoxies, better use a scale to get a proper mixing ratio. When it comes to epoxy acrylates or polyesters with the hardener, usually the workers after a while, they know what is like 1-2% of hardener. So in the beginning, if you're not skilled, also use a scale, but later on, usually they can do it by eye. Yeah. Also, what we can do is we have some products in tubes, yeah, especially the Archipops 5010 or 2010. So here it's quite easy. You don't need a scale. I show you what to do here. Maybe Otello, we go into the, yeah, here we are. Yeah, so here you take, it's a 2:1 system. You take A component, you make like 1 line, 2 lines of the A component, and then you take the B component, make again 1 line in the same size. And then you see this is a 2:1 mixing ratio. I think everybody can do that. So as I said, you don't have to go here for the last gram, but roughly this has to be the mixing ratio 2:1, but with these lines, you're quite good. So then mix proper. And here it comes to the proper mixing because this is an epoxy, so it's an adduct system. So you have, it's a key lock system. So two parts of the A component have to get in contact with one part of the B component. So, and if this is not happening, then you will not have a proper cure. So please spend here at least like 30 seconds, 1 minute to get a good mixing. Yeah. With polyesters, it's a little bit more easy because it's a polymerization. There, when it gets like knocked with the hardener, it starts a chain reaction and gets cured. So, but still also there to get a proper result and a proper, let's say, homogeneous curing. Also here, use like 30 seconds to 1 minute to mix your mixture proper. Good. So now I have a good mixed adhesive, 2:1 epoxy, and now I could start filling some joints or doing some bonding. Are there any questions, Otello?
Yes, one viewer is asking, what about the coloring? Do I add the color after mixing the components
No,
or
before.
before?
Good question. So you've seen the Archibox 5010, the color is quite bright. And it stayed quite bright when I put the hardener in it. So here what you can do is you make your 2 lines or 3 lines. Yeah, same. Then you put the B component, the A component aside and mix the color in it until your color is a good match. And then you add the B component to adapt it. With a color concentrate, it works because you have only 1% color concentrates. It does not mix up your mixing ratio. Yeah, when it comes to crushed stone powder, now this would be the moment already mixed. Now I would add some stone powder and mix it again. And then I would start to fill it or put it into the hole. Okay. More question?
No more questions for now.
So, do we have something to demonstrate here or we move on to the...
We can now move on and later on we can show the rest.
Okay. Yeah, good. Thank you, Otello. So we move on with the presentation. Okay. Now, right adhesive was chosen. We have cleaned the bonding surfaces. We have roughened the bonding surface. We have dosed and mixed our glue. Now it comes to the application. What can be done wrong here? Movement of the bonded components during the curing phase. Yeah, this is the problem because then I will show it later to you, but then when you have, let's say, put the glue on both sides of your substrate, you press it together, yeah, it's all good. And then you say, nah, and you start opening and closing it and opening and closing it and moving it. First, you will suck in a lot of air. Yeah, it's like a vacuum you create. There will be some cavities, some lines of air, which you suck into the bonding area, bonding seam, and this could cause problems later. Another thing is when it starts already to cure. Yeah, maybe you are after this 20-30 minute working time and you start moving it. Also then the glue is not yet hard and you move it, you try to pull it somehow because you messed up maybe the adjustment. Then the polymers have already started to cross-link. Yeah, and so you rip off this polymerization, for example, and then also your bonding could fail later on. So this is important. When you once pressed your 2 pieces together, you moved it into the place, leave it like that. Don't open it up again and don't move it until it's hard. It looks like that, especially on the miter bonding. It's important, but it's more like let's say an optical problem. Not so much a structural problem when you go for the miter bonding in the countertop industry. You have the 45-degree miter, you put the glue inside, then they press together, they squeeze together, and then they start, oh, I messed up my adjustment, and open it again, close it, open it. So they pull in, they suck in these lines. You will see it later better on the application table, and this will cause big problems. So first, what does it do? After grinding and polishing on your miter, you will see these are the air holes, which you pulled in earlier. yeah, or which you sucked in earlier. So in this case, on a mitre bonding interior, this is only an optical problem. So it does not look good. So you have to work again. You have to fill it again, wait, grind and cure. So this is more, let's say, extra work, but it's not, let's say, a big problem, yeah, for later on, but it's for you extra work and does not look good. When it comes to exterior application and you have done that, so this could be a big problem because in these openings, humidity can go in, water can go in, water can freeze, expand, and break your bonding. That's like here, air inclusion due to a vacuum. You open it and close it, and then it gets sucked in here and here. Yeah, the drawing with the mouse is not so easy. So it gets sucked in here and here, and then cause some problems. Yeah, how it looks good or in a proper way, how it should look is this. Now you can see on the left side, they clean with some alcoholic cleaner, remove all the dust and greasy fingerprints. Then they use a cartridge, so the mixing ratio is proper. In this case, they use color bond. They fill it down into the mitre, in the beginning of the mitre, the right amount, directly down, so there's no air bubbles there. A proper line. You see also the metal, the ceramic was cut with a water jet, so you have a good rough surface there. They adjusted it proper in the first place, and then they just move the front, tape it. You can also use clamps, so there are a lot of different techniques here, but you can see here, yeah, they did it in a proper way. Enough glue, the adjustment was done before, yeah, no opening needed, and you can see here now, the right amount of glue comes out here, here, and here, and also on the inside. So here you are sure the whole mitre bonding is covered by a glue, and you will not have any air bubbles, and you will not have any problems later on. And then you will have a nice countertop with a nice mitre bonding. Good. And I think I will show you that now in a practical demonstration. Or have I missed anything, Otello?
You haven't missed anything? No, it's all in time or everything fine.
All fine? Okay, good. Then let's move over to the table. So first, yeah, I think I showed the ceramic. Yeah, did I show it already? No.
Just in a picture. We can show it now in the cam.
Yeah. So this is this typical ceramic cut with a diamond blade, and I try to get it here into the camera. Yeah, here you see it. Yeah, this is a fully polished surface, and this is just from the cut. Nobody was sanding there afterwards or polishing or anything. So this is the cut, and this is much too smooth for proper bonding. You can see here it's a polished surface. Oh, here you can see it better. Nice. So yeah, no way of a good adhesion here later on. Yeah, so always make it rough, and then you can see also here my greasy lunch finger I placed there. So this is also not a good good preparation for bonding. So it must be rough, it must be clean. So how does a rough surface look like? Yeah, here natural stone it's more easy. You can see here a little bit the blade from the cut is there. So you have a rough surface. Of course, now I have put also here my greasy fingers. I will clean that shortly. When you use water jet for cutting your stone or ceramic, perfect. Yeah, usually the cut is rough enough. Yeah, we clean. And what we use for clean? We use alcoholic cleaner, like our cleaner eye. We don't use acetone. Why we don't use acetone? Of course, it removes grease and remaining humidity and maybe also some glue or something and some dust, but acetone evaporates extremely fast. So that means, probably all of you know, stick a finger into acetone or get a drop of acetone on your hand, it will be really cold. Yeah, because of the evaporation energy, your finger becomes very cold. The same happens with your stone. In the area where it evaporates fast, it becomes really cold. And this is a problem in a warmer time of the year, because usually it has a lot of humidity in the air, and then you get condensation water on the bonding area. And this water film, this small water film, again, is not good later on for proper adhesion and bonding. So we use cleaner eye, alcoholic cleaner, or child lock. Okay. The right hand does not open it, the left hand does. Okay, interesting.
It's all about the technique.
Yeah. So I use some cleaner eye. I clean my stone here. Yeah, all the dust must be gone, all the grease must be gone from my lunch. And now the good thing is with the alcoholic cleaner, it does evaporate, yeah, but not as fast as acetone. Yeah, so also here I don't lose any time. Yeah, I'm quite still fast. I'm still quite fast, but not as fast as not as cold with it like with the acetone. Good. Now I could, because I have here my glue, my Archibox 5010, I could use it now because it's still workable, yeah, because we have 20 minutes working time, and with it is already mixed right, I can fill it in. But as we talk about cartridges and miter bonds, kitchen countertops, we use our color bond. Also here, mixing ratio, you cannot do any mistakes, but you have to be sure that the mixing ratio comes out in a proper way. So we use first, when you use a cartridge, the first time, press as long as both components come out of the chambers. Yeah, because maybe during transport and so on, there will be a different filling status. So press them out so you're sure they come out at the same time. Place your mixing nozzles on top of it. And again here, we press, and you can see here the A and B. Yeah, the white is the hardener, gets mixed. Here it still is visible. Here the mixing ratio is good already. It's all proper mixed. So one homogeneous color, but still we want to be 100% sure. So we throw 2-3 centimeters. First, we don't want any air bubbles. Yeah, and second, we want to have a proper mixture. Good, let's throw that here. And now we go on the top and place enough glue that it comes out of both sides into the miter. Yeah, and I don't move here like in zigzag. Yeah, because then when I press together, I already trap some air inside. So I start from the bottom, I filled everything from the bottom, and now I press it together. And now I press it one time together, I don't open it up again. So I press. Usually I put here my 90-degree angle, check if it's good. I check here, the right amount of glue comes out. Yeah, and now I don't open it up again. Yeah. Why? Because if you do that, we have done it in the morning here, you can see here what happens. You see this? These are the air channels or the cavities you pull with the vacuum into your bonding. Up, open, close, open, close. Yeah, now it's cured. Yeah, but this will be also in your bonding. So don't open and close your bonding. Measure proper, adjust proper, and press it together one time. Then you will also have no issues there.
Johannes, there's a nice question actually, which is perfectly now for this topic. Viewer is asking, how much glue do I need?
Yeah, as I said, you need so much glue that both sides of the stone are filled with glue, are touched with glue, both bonding sides. Yeah, so there must be. You can also work when you have, like, say, normal bonding where you place just 2 stones together. The best thing is to apply glue here and here, and then press them together, that on both sides, glue comes out, yeah, in a homogeneous line. Yeah, not like here's coming out and nothing, then here's coming out and nothing. I will show you a few pictures later. So that must be enough glue. Cover both sides. Of course, a special case is this miter bonding with the 45-degree because it's usually online. They do a lot of running meters there in the production. They want to work fast, so they don't go with the spatula and apply on one side and another side and then press together. They do like what I've done. They go in the center. They press a lot of glue. They don't go zigzag, so they go in the center. They put the glue inside enough that when they press together, that it comes out on the one side and on the other side. Yeah, usually it should have come out here as well, but I placed my tape here on the full side because I don't want to mess up my table here. But usually you can use the tape like this, and like that, and then here the glue comes in the middle out. Usually ColorBond is not dripping, so it stays like that. Does not mess up your work floor, workshop floor. That's the right amount of glue. More questions? Okay, good. Then we go back to the desk. Yeah, okay. Insufficient amount of adhesive. Yeah, this was the question. What happens when I do too little glue? Yeah, you see here, this is ceramics, outdoor ceramics bonded on mitre for mitre bonding, probably maybe for pool surroundings, steps, I don't know. And you can see it's small openings here. Yeah, this does not look much. Yeah, but then after 1-2 years, frost thaw changes, a few winters, suddenly this front comes off, breaks, and then they call us and say your glue did not stick, and then we say send some pictures or the pieces, and then we get that. Yeah, and then I say okay, that's not enough glue. Yeah, you can see here there's a lot of air inside. No glue there. You can see the glue was sticking. Yeah, the glue was proper because it ripped out some part of the ceramic here. So the adhesion was there. Yeah, because here in the front, because it was small, maybe they pressed together here a little bit. There was enough glue, but later on, yeah, there was not enough glue. And what happens outdoors, especially when it's like swimming pool surroundings, water will be here, water will be there, water will be there. And what happens in the wintertime, water freezes, and when water freezes, it expands. And this happens here. So there's always a limitation to a bonding, yeah, because bonding are good when there is pressure on it, yeah, a bonding is fine there. But when there is like, was heißt Scherbewegung, Othello? It's a tensile? Yeah, when it's at least when the force comes not like a pressure force, but it's like on a scissor, it's opening up, yeah, and this is what happens here. The water is inside, it presses outside to the outside, it expands, and then it presses the bonding away from each other. And this is the most worst case which can happen to a bonding, and then it will fail. Yeah, and even when I see here this line, you can see here they applied with a cartridge, and it's still glossy. It does not even touch the other side of the ceramic here in this case of the mitre. It did not even touch the other side. So you know there was a huge gaps in between. This can never work proper at the exterior environment. Yeah. Also here, you see here from the front, it's opening. Here they glued a little bit. Yeah, here it's open. There comes the glue out. Here it's open. There comes the glue out. Here it's open. So I can bet money on that in 1, 2, 3 winters, this bonding will fail. Yeah, and then it's not a problem of the glue. Yeah, that's a problem of not enough glue and not a proper filling. So have that in mind. Enough glue is needed to cover all the bonding area. No opens, no gaps, no air where water can go inside and causes some problems. So the application must be done right. We do that. Now there could be also environmental parameters which we have to have in mind. What do we mean by that? First, temperature. Yeah. Heat shortens working and curing time. Too cold, the reaction falls asleep. Yeah. Not a proper adhesion, not a proper curing. Example, for example, our color bond glue. Yeah, it has a working time at 20 degrees. We call it 6 minutes. So it's roughly between 5 to 7 minutes. It's the working time. Now we have 30-degree environmental temperature, only 3 to 4 minutes working time. 40-degree, 1 to 2 minutes. Yeah, so it becomes quite tight when you want to bond, let's say 2-3 meter of a mitre. Yeah, when you have like a nice island top countertop and you have to do a few meters, yeah, let's say 5, 6, 7 meters around, and you put everywhere the glue, and suddenly after 1-2 minutes, it starts to get chilly. Yeah, it starts to cure. Then when you start to press the mitre together, the stones together, then you, again, the polymers started to react already. Yeah, so they will not have a proper adhesion, a grab and tag to the stone then. So to have that in mind. When it's very warm, one thing you can do is put that color bond into a fridge, not a freezer. Yeah, put it into a fridge, like 8 to 10 degrees Celsius. Then you double the working time. Yeah, what goes in this way goes, of course, also in the other direction. 10 degree means here about 10 to 12 minutes. So when it's warm, place your products into a cool area. Don't put it into the car. Yeah, when you go to a site, the car gets heated up to 50 degree maybe. Yeah, then you don't even have to start with bonding. So when you work in the workshop, put it into the fridge. Then you have like 10 to 12 minutes. When it comes then in contact with a warm stone, a stone like 30 degree, yeah, then you more or less, the glue gets heated up, then you, yeah, reach again your 5 to 7 minutes working time, which is proper, which is usually fine. The other way, when it gets too cold, yeah, curing is the problem there. Yeah, not the working time. Usually everybody is happy when he has more working time. But the curing time, then a problem. For example, Archibox 5010, 20 degree, 12 to 16 hours. 10 degree, 24 to 32 hours. 5 degree, 30 to 40 hours. Yeah, it's a long time where a lot of things can go wrong. Yeah, somebody moves the particle to the stones. So you open it up again, then again happens air debonding, not a proper adhesion. So this can happen. The second thing is when it becomes too slow, also there is not a good curing, and it can, because the glue stays liquid for a long time, you can cause some bleeding, which we said earlier, left and right on the bonding seam. You can get some dark discoloration because the glues does never really proper get hard. So all the liquids, they start moving into the stone. Yeah, usually an Archibox, yeah, you have working time 20 to 30 minutes. Yeah, it starts to get G-like after 1 hour, maximum 1.5 hours. So there's no moving into the stone anymore. But when it comes to 5 degree, maybe the glue stays liquid and soft for 4, 5, 6 hours. There's a lot of time where this polymers can start moving into the stone and can cause a discoloration. So when you have to work with a epoxy outside and it's maybe 5 to 10 degrees, then take your cartridge out of your workshop, so the cartridge has a proper temperature or the glue has a proper temperature, and go with a gas flame and heat your stone. Yeah, 20, 30, 40 degrees, no problem. The stone keeps the heat for a few, at least let's say 30 minutes. Yeah, and this usually is enough that the glue, the adhesive, the epoxy gets its start reaction. Yeah, maybe then later on it cures also a little bit slower when it gets colder again, but at least the first 1-2 hours, the reaction started already in a proper way that the glue gets gel-like, rubber-like, so it starts to react and does not move anymore into the stone. So when you use adhesives outside and it's quite cold, heat the stone, but below 5 degrees, I would not start working anymore. Good. Are there any questions to that, Otello?
No questions for now, Johannes.
No questions for now. Then another parameter, environmental parameter, is moisture. Yeah, this is not always a problem. Some systems, like for example the Akemi, which I showed you earlier, the polyhybrid adhesive, the elastic one, they need air humidity to cure. So when the stone is slightly humid, they take it. They are happy. Yeah, then this Akemi products, they start curing in no time, and it's quite good actually. But when it comes, for example, to polyester, epoxy acrylate, or even worse, a polyurethane product, doesn't matter what polyurethane, they all behave the same. For polyurethane products, humidity is a killer. Yeah, you can see here, we put the stone, we made it wet by a, I don't know, paintbrush or something. And then we applied some polyurethane product here. We flatten it and see what happens. It starts foaming, a lot of bubbles appear. So, which is maybe nice to have at these polyurethane construction foams. Yeah, they foam, they fill something. Okay, it's good here, but in a bonding, yeah, it's a no-go. So the stone must be, when you use polyurethane, absolutely dry. And not only on the surface, when you see at these holes and cracks and capillaries, the stone must be also inside dry, because then this will happen. And when you can see here, there's no adhesion, you can just pull it off. Yeah, polyurethane products, doesn't matter what type of polyurethane, the stone must be dry. Epoxy systems, of course, everybody knows our Archipox range. They can take a little bit humidity, but also here, the stone should not be like dripping wet. Yeah, make the surface dry, but if there's some remaining humidity into the stone, epoxy product can handle that, but all other bondings must be dry if it comes to polyester, epoxy acrylate, and so on, and especially polyurethane. Good. Are there questions to moisture? No?
Not yet.
Good.
Yes.
Then we nearly in the end. Now we have checked everything. Selection of adhesive. We have chosen the right product, interior application or exterior application. The bonding surfaces are rough, clean, and neat. We have dosed the right amount. We have properly mixed the glue. We have done a good application, the right amount of glue. So we pressed everything good together. The temperature was okay. Yeah, but then there can be still one thing. The construction or the object, the building system itself, yeah, the requirements have a problem. What do I mean by that? Maybe this is not a proper English translation from the German, but what do I mean? I mean something like that. Yeah, you have a wooden door of a cabin and you placed some stone on it, some natural stone. Maybe it's interior, you used also the right glue, the bonding is perfect, but there is a problem. Yeah, because this sandwich construction somehow behaves weird. You don't know what it is. Maybe it can catch again some humidity and you have this bending. Yeah, so this is a flat one. This one moved and bended itself. There was moisture in the bathroom was the problem. So have that in mind, that the substrate, the stone and the glue is right. So there was not a debonding here. Yeah, this is all good, but the combination itself was not right for the application, maybe for the bathroom. So we should not have used here wood, for example. Yeah, maybe to explain it in a better way. You have here a swimming pool, you have a outdoor ceramic, and the ceramic cracks suddenly. Yeah, and you look, you have done the right amount of glue, the right glue you use, the adhesive is an outdoor adhesive, it's perfect, frost door stable, but here the problem was the substrate itself, the ceramic. Yeah, here it broke into in the ceramic. So the bonding was good here. The ceramic itself was the problem, because what was happening here? Some natural stone, some material, you saw the wood earlier, but also it can happen with stone, it can happen with ceramic. They have, let's say, a tendency to bend when they get in contact with humidity, especially when they get in contact from humidity from one side or heat. Yeah, and especially when the heat comes on the top and maybe it's cool underneath. So this ceramics, porcelain, or stones, they want to bend, so they want to move. Now, what we do? Yeah, they want to move. Usually, it's not a problem. When you have it in a flooring tile, outdoor terrace or so, you have a movement there. Yeah, maybe you have a little bit of a high edge. Yeah, so you hit your small small how you say, kleiner Zehe, your small toe. Yeah, you hit yeah, because it's a little bit higher there. But in the end, there's not a problem. Yeah, but now, when you do a mitred bonding there, yeah, you lock the tile. So the tile still wants to do that, yeah, but you lock it from the front side because you put a mitred bonding there, and then it cannot do that. Yeah, so there's a lot of force, a lot of tension inside the system. Yeah, this structural system. So it's all the same material. It's ceramic. The glue is proper. It's outdoor glue. It has a good adhesion, but there's a lot of tension inside this yeah, building component, how you call it, this structure, and then it will break in some point at the weakest. Yeah, in some time at the weakest point, and this is maybe the tile itself, maybe it's in the bonding area, you never know. Yeah, and especially when it comes to outdoor ceramics, some of them, this is a cut from the top. Yeah, they look like that when you cut them. They are built like a sandwich. They have 2-3 different materials burned together. Yeah, or maybe it's like one material but differently burned. So it's definitely harder here than here, and maybe different here. And then you have humidity, then you have temperature, and then this thing behaves like a sandwich. I'm not sure if all the manufacturers are aware of that, yeah, of this ceramic manufacturers. So, and then it tries to bend. And now when you lock that with a mitred bonding, then you will have a lot of tension and can create some problems. So if you have that, or you're not sure if your ceramic or your stone is doing that, yeah, we have here this mitred bonding. So now this wants to bend. Yeah, this wants to bend, and maybe in this area or maybe in this side. And you're not sure if your ceramic is doing that or your stone, we recommend, yeah, place here a stainless steel angle, bond it there, let's say with a flexible glue, because then you have now again steel to ceramic, different expansions. Use it maybe with our Akemi, bond it there, just to reinforce. When you're not sure if your ceramic wants to do that, or your stone, reinforce the back side. Then you're on the safe side if your ceramic is doing that. If you're sure that it does it, maybe you have seen it already, or yeah, you have it outside and so on, especially when they are bigger, like when they come to 1 meter, 1.20 meters in length, and when they start moving, and you're sure your material is doing it, then I will not take the risk. Use directly here a flexible glue like our Akemi elastic, for example. Akemi elastic, we have it in several colors. They are UV stable. So use them directly here. Don't risk it. Bond it rigid. Yeah, because when it starts doing that, and in the front there is your mitred there, there will so much tension in this system, which can cause problems. Maybe if you're not sure, just call us, write us, send us your materials, send us pictures of your construction. We will help you there to choose the right glue, the right adhesive to fix your stone, your tile, your mitred bonding, etc. Or yeah, just a message should be, you can do everything right, but have in mind that sometimes the construction itself is the problem, yeah, because it creates a lot of tension there. Good. Are there any more questions, Otello?
Yes, one viewer is asking, what if I have done already a mitred joint bonding? How do I remove the glue again?
Yeah, usually not. Usually our products are meant to be there. Now, if you have installed it already and it's there, you can only remove our adhesives with a lot of heat. So like 250 degrees Celsius plus. So they get a little bit soft. You can start using a cutter knife or a blade to open it up, clean it, grind it, but there's no way to remove the glues. It's also not meant to be, because they should last, especially the outdoor adhesive, for decades, not only for 1 to 3 years. That's the only way to remove them. Does that answer the question? Yeah. Thumbs up from Otello.
Yes. Thumbs up.
Okay, good. So better think before you install it, or contact us so we can recommend the right product for that. Just to go again through the steps which are important. Yeah, select the correct adhesive system for the right application, interior, exterior, rigid, flexible. Yeah, if you do a lot of repair works, filling of large holes, use products with a low shrinkage, for example, epoxy-based products. Roughen and clean the adhesive surface, also dust-free. Correct preparation of the adhesive, yeah. Prepare sufficient quantity of adhesive. Mixing ratio must be right, the right quantity of hardener. Mix it right. Yep. If you use a cartridge, do the chamber adjustment that out of both chambers glue and hardener is coming out, and respect the working time and curing time, and then you're usually good to go. And only in a few cases, the whole construction design has a problem. But if you're not sure, contact us and we will happy to help you. Good. So that was that for today. Thank you for joining again. Now we will have a little bit of a summer break with the webinars. The next one will be in November. It will be an exhibition review. So after after our Verona exhibition, and maybe in the meantime, we'll see us all in person, take some exhibitions, at some trainings on some sites. So if you have any requests, please call us. We are happy to help. So thank you for joining us again, and see you soon.